Okay, determining Young's modulus of a metal wire. So this experiment looks easy, but actually it's not, because if you understand what is a metal, it's supposed to be rigid and is strong, it's hard to be extended. So what you need actually is a very heavy load to just extend it by a little bit, probably an nm or a 2 mm. Okay, so then this will cause some problems if you want to conduct this experiment in the lab. So if you look at this picture here, it already tells you some problem. Okay, so you pause the video and see whether you can identify some challenge if you want to conduct this experiment. Okay, just pause the video and think about that. Okay, so let's look at that. As I mentioned just now, you actually need a very heavy load just to extend it by a little bit, and in order to get a significant extension, actually you need a very long wire. Then only you can see the 1 or 2 mm that I mentioned just now. So then it gives you a problem, because in the lab you have meter rule. So let's say you use 2 meter, then it becomes very difficult. Okay, you need a special design for this, and we'll talk about that later. And also, if you want to hang this, on a ceiling, that will cause the ceiling to yield down. Okay, you will cause the ceiling to be deformed a bit. Okay, that's not suitable. So it does not stretch easily. So these are the points that I mentioned just now, that you need very large stress, and the wire has to be very long to get significant extension. So modification to this experiment or the setup is necessary. That is called the Schiller's method, and actually you need to describe that, describe the experiment. I will talk about that, and how to find until the step of getting the Young modulus. So we go step by step. Yeah. So first of all, when you talk about this, you have to tell that there are two wires. One is a reference wire and one is a test wires. So when you have a reference wire, that wire have to be kept taut. Okay, just straight, no kinks and bends and all that. So the other side here, where you this is the wire that you test, and you put some load here. Okay, so what is the use of this reference wire is that you can attach a vernier scale. Okay, so this is a vernier scale, just like the scale on the vernier caliper. So it shows you movement, tiny movement that can be recorded in terms of mm, when you compare the two scale there. All right, so when the load extend, the it will go down a little bit, but the slight movement will cause the scale to go down, and comparable, or can be compared with the scale that is uh, attached to the other side. Okay, so the other thing about this reference wire is good, is because let's say you really cause the support there to yield. So reference wire and the test wire, actually they come down together. So in a way, it actually doesn't cause any inaccuracy in the comparison using the scale. Okay, so now you have this set up. So first thing, you need to apply the Young modulus equation, that you rearrange until you get the manipulating variable and the corresponding variable. Manipulating variable, of course, is the load, right? The force. As you add more loads, the force increases. Okay, so you manipulate that. So for example, 1 Newton, 2 Newton, 3 Newton, and so on. Then you look for the extension x. So which means that we need to move the x to become the subject of the formula, and f to the other side. So once you rearrange that, you can now plot a graph. Okay, so you plot a graph, and from there you have x equals to 1 over L over E A times F. So that's after you rearrange it. Okay, so I would like you to try out this process of rearranging them, okay, because it's important for you to know how to do that. So once you've got that, then the gradient of the graph that you plot will be L over EA. So L over EA, before you get E, of course you need the L. L is the original length, so that one can be easily measured using a meter rule, because this one is not like the previous situation just now where you need a very long wire. So this one within 1 meter should be fine. So you also need to measure the to get the cross-section area, which means you need to measure the diameter. So diameter of a wire, you can use a micrometer. Okay, so use a micrometer, get diameter. Then after that, use equation pi d square over 2, pi d square over 4. Then you should get the A. So together with the gradient equals to L over EA. Then you should get the Young modulus. Okay, so that's the Schiller's method.